Section 7.4, least common denominator of rational expressions. So, the least common denominator usually denoted by least common denominator is the same as the least common multiple of the denominators. So you would find the least common denominator by just looking at the least common multiple for each of the denominators in each of the rational expressions. So let me do some examples. So it turns out that dealing with a variable will actually not be any more difficult, actually be easier than dealing with numbers. So let's do some examples. Page 277. Problem number, let's say 2. 2 over x and 3 over y. In exercises 1 through 20, find the least common denominator. Well, the least common denominator of 2 over x, 3 over y, which is the same as the least common multiple of xy. Since x and y are relatively prime, they're different variables. You'll find the least common multiple by multiplying them. And so the least common denominator is x times y. Let me do problem number 4. A minus 3 over b, a plus 4 over b cubed. So the least common denominator in this case is going to be, I have b and b cubed. And so least common denominator is just, in this case, since the highest power of b is b cubed, then the least common denominator is b cubed. Let me do problem number 10. Two x plus 1 over 3x plus 4, x minus 1 over 3x minus 4. And so the least common denominator in this case is just going to be the product of 3x plus 4 and 3x minus 1, 3x minus 4. So 3x plus 4 times 3x minus 4, because each of these are relatively prime. So the least common denominator is found by just multiplying these two denominators together. Let me do problem number 14. 2x over x squared plus 6x plus 8, and x over x squared minus 16. So I want to find the least common multiple, least common denominator, which is the least common multiple of the denominators, x squared plus 6x plus 8 and x squared minus 16. Well, let's factor each of these. And so it's the least common multiple of, well, x plus 4 times x plus 2. And x squared minus 16 I can factor into x minus 4, x plus 4. And so to find the least common multiple, I have 1, the highest power of x plus 4 is x plus 4 to the first. Of x plus 1, the highest power is x plus 1 to the first. And of x minus 4, it's x minus 4 to the first. And so those products is equal to the least common multiple. Let's look at problem number 18. 2 over 2a cubed plus 2a squared minus 4a, and 3 over a cubed plus 2a squared minus 3a. So first, let me factor 2a cubed plus 2a squared minus 4a. Well, there is a 2a in common. And so factoring out 2a, I get a squared plus a minus 2. So now I can factor what's in the parentheses. This is a monic polynomial. Bring down the plus, times minus is minus. I want to find two whole numbers whose product is 2 and whose difference is 1. 2 and 1. Next, let me look at a cubed plus 2a squared minus 3a. Well, what's in common is a. What remains is a squared plus 2a minus 3. And so, again, this is a monic polynomial, so I can factor this as follows. Bring down the plus times minus is minus. I want two whole numbers whose product is 3 and whose difference is 2. 3 and 1. Therefore, the least common denominator of all the denominators is just going to be, well, there's a highest power, what the highest power of 2 is 2. Of a in common is a. Of a plus 2 is a plus 2. Of a minus 1 is a minus 1. Of a plus 3 is a plus 3. And that is the least common denominator, the least common multiple of all the denominators in this particular region. Let me do, let's say, problem number 20. Yeah, let me do problem 20. Three over x squared minus x minus 2. 4 over x squared plus x minus 6. Negative 5 over x squared plus 4x plus 3. And so let's factor each of the denominators. And so this is a monic polynomial, so I can factor it as follows. I have a minus sign, so let's bring down the minus. Times minus is plus. I want two whole numbers whose product is 2 and whose difference is 1. So 2 and 1. X squared plus x minus 6. So let's factor this. Again, this is a monic polynomial. Bring down the plus. Times minus is minus. I want two whole numbers whose product is 6 and whose difference is 1. 3 and 2. And lastly, let's factor x squared plus 4x plus 3. And so this again is a monic polynomial. Bring down the plus, times plus is plus. I want two whole numbers whose product is 3 and whose sum is 1. 3 and 1. And so let's find the least common denominator. And so the lowest power of x minus 2 in this list in common is x minus 2. Of x plus 1 is x plus 1 to the first. Of x plus 3 is x plus 3. And that's it. there are three differing prime factor polynomials in this case. Let me do problem number 22. 3 over 2x minus 4, 1 over 3x minus 6. In exercises 21 through 56, find the least common denominator and rewrite the rational expression with the LCD as the new denominator. Okay, so let me do that. So first, let me write the first rational expression as well. That rational, let me factor the denominator as much as I can. Well, I notice that there's a 2 in common in the denominator, so let me factor out a 2. What remains is x minus 2. Similarly, I have 1 over 3x minus 6, so let's factor out a 3 in the denominator. So I get 1 over 3x minus 2. And so the least common denominator in this case is 6x minus 2. So I need to multiply and divide this first rational expression by 3 in order to obtain an equivalent rational expression with the same common denominator. 3 times 3 is 9. For the second, I've got to multiply and divide by 2. 2 times 1 is 2. And so I've rewritten each of these rational expressions as equivalent rational expressions with the same common denominator, 6 over 2 x minus 2. Let me do problem number 28. Three x over 3x squared plus 2x minus 1, 1 over 3x minus 1. And so I have a 3x over 3x squared plus 2x minus 1. I have 1 over 3x minus 1. Let's factor the denominator. So this factors into 3x minus 1, x plus 1. And so notice that, oh, here, wait one second. Let me make that a little smaller. So notice that 3x times x is 3x squared, plus 3x minus x is plus 2x minus 1. So I have the least common denominator in this case is, well, 3x minus 1 times x plus 1. And so we have the following. So 3x minus 1, x plus 1, 3x minus 1, x plus 1. So you already have a common denominator, so you don't have to do anything for the first one. For the second one, well, I have to multiply and divide by x plus 1. 1 times x plus 1 is just, well, x plus 1. And so the least common, and so the rewriting each of these rational expressions with the same least common denominator is, well, so this is the, I found equivalent fractions for each of these rational expressions with the same least common denominator. Let me do problem number, let's say 32. X over x minus 4, x minus 1 over x squared minus x plus 16. And so let me factor the denominator, each of the denominators. Well, this, of course, has already been factored, so you don't have to do anything here. For this, well, this is a perfect square trinomial. Square root of x squared is x. Square root of 16 is 4. X times negative 4 times 2 is negative 8x. And so, yes, it is indeed a perfect square trinomial. And so the least common denominator is x minus 4 squared. And so I need to multiply and divide by x minus 4. So let me multiply x inside the parentheses. And so I get x squared minus 4x. And thus we have found equivalent rational expressions with the same common denominator, least common denominator. Let me do problem number 40. 2x over x minus y, y over x plus y. Okay, so let's factor. Well, I've already factored. Can't factor that. Can't factor this one. The least common denominator will just equal, oops, that looks like a 4 rather than a y. The least common denominator is found by multiplying each of these denominators, x minus y, x plus y. And so let's multiply and divide by x plus y, x minus y. And so let me multiply 2x inside, 2x inside the parentheses, and then y inside the parentheses. And so I get 2x squared plus 2xy, xy minus y squared. And so I have found equivalent rational expressions with the same least common denominator. Let me do problem number 48. Let me do problem 48. One over x plus 1, x over x minus 2, x squared plus 2 over x squared minus x plus 2. So I have 1 over x minus 1, x over x minus 2, and x squared plus 2 over x squared minus x plus 2. Let me factor the denominators. And so I get x minus 2, x minus 1. And so these have already been factored. So the least common denominator is just x minus 1, x minus 2, x minus 1. Let me multiply and divide by x minus 2 by x minus 1. Well, you already have the common denominator at for the very last one. And let me multiply x inside the parentheses. And so I get x minus 2, x squared minus x, and well, multiply by 1. And so I have found the least common, oops. Okay, so I found the least common, uh, I found equivalent fractions with the same least common denominator. Let me do problem number 54. Let me do problem 54. X squared, 1 over x squared. And so I have here x squared, 1 over x squared. Let me rewrite this as x squared over 1. Well, the least common denominator is going to be x squared. So I have to multiply and divide by x squared by 1. So I get x to the 4th and 1. And I found equivalent fractions with the same least common denominator. Let me do problem number 56. Two over x minus 1, 3 over x cubed, x over x plus 1. And so I have here that, well, each of these are factored as much as possible. So the least common denominator, it will just be x cubed, x minus 1, x plus 1. Okay, so let me multiply and divide by, well, I need an x cubed, and I need an x plus 1. I need an x minus 1, x plus 1. I need an x minus 1. Oh, maybe I should write x minus 1, x plus 1, of course, is x squared minus 1. So I'll write that. And I have here an x cubed, x minus 1. Oh, so let me write that as x to the 4th minus x cubed. And actually, I should do that for this one too. Let me write this as x to the 4th plus x cubed. So let me multiply 2 inside the parentheses, 3 inside the parentheses, and x inside the parentheses. And so I get 2x to the 4 plus 2x cubed, 3x squared minus 3, x to the 5th minus x to the 4th. And so I have found equivalent fractions with the same least common denominator. Let me do problem number 56. Oh, that was problem 56.